In this session, we are going to discuss line coding. In digital techniques such as PCM, DM and differential PCM, binary sequence in form of ones and zeros is produced at the transmitter side. And there is a requirement to convert this binary sequence data into any electrical representation which is easy to understand and convey some information. So here line code is used to convert binary sequence into most appropriate form, and they are on-off signaling, non-return to zero signaling, that is NRZ, return to zero signaling, that is RZ, bipolar return to zero signaling, that is BRZ, split phase or Manchester code, and last differential encoding. To understand these line coding, we consider any binary sequence that is generated at the transmitter side, and here we take for example 0 1 1 0 1 0 0 1. Now the first line code is on-off signaling. In this, symbol 1 is represented by a constant amplitude and symbol 0 is simply switch off, means zero amplitude. That is shown in first waveform. Next is NRZ signaling, that is called non-return to zero. Here symbol 1 and 0 are represented by pulse of equal positive and negative amplitude respectively without returning to zero position. While in case of return to zero, that is called RZ signaling, the width of the rectangular pulse is just half and symbol 1 is represented by positive amplitude, and for symbol 0 there is no pulse transmitted. In RZ signaling, in case of symbol 1, the rectangular pulse with half width always return to 0. So here we note a point. In RZ signaling we use half of the symbol width as compared to NRZ signaling. Next is BRZ signaling, that is called bipolar return to zero. In this, three amplitude levels are used. Symbol 1 is represented by alternate positive and negative pulse, while for symbol 0 there is no pulse. As shown here, symbol 0 represent no pulse, and for symbol 1 there is alternate positive and negative pulse. Also in BRZ signaling, there is no DC component in the power spectrum of transmitted signal. Next line code is Manchester code or split phase code. This code also suppresses the DC component using rectangular pulse of half width and constant amplitude. Here symbol 1 is represented by positive pulse followed by a negative amplitude pulse, and for symbol 0 the negative pulse is followed by a positive pulse. Just reverse the polarity of half width rectangular pulse in case of symbol 1. And the last line code is differential encoding. In this, we first consider any reference bit. It may be 0 or 1. And here we take reference pulse symbol 1. In differential encoding, if the symbol is changed with respect to reference bit, then encoded output is 0. But if there is no change in symbol with respect to reference bit, symbol 1 is encoded. For example, for first symbol there is a change, so output is 0. Now this encoded 0 is taken as a reference bit for the next symbol and compare again, and here there is a change, so we mark it 0. Similarly for third symbol, but for fourth and fifth symbol, there is no change. And in this situation, symbol 1 is encoded in the output. And accordingly, we get the encoded sequence that is called differential encoded sequence.